So let's proceed to Roman 2. That is identity Roman 2. We want to prove it. So it also begin from alpha plus beta cubed. So it means this one is appearing 2 times. This one can be like alpha plus beta, again into alpha plus beta squared. So when we expanded this, we came out with, this is alpha plus beta into alpha squared plus 2 alpha beta plus beta squared. So can we try to use our layman's understanding? So we are going to say alpha into the second bracket as it is containing alpha squared plus 2 alpha beta plus beta squared, then plus beta into alpha squared plus 2 alpha beta plus beta squared. So let's try to open the brackets. Alpha times alpha squared, we are coming out with alpha cubed plus 2 alpha squared beta plus alpha beta squared plus beta times alpha squared, we are coming out with alpha squared beta plus 2 alpha beta squared plus beta times beta squared, we are coming out with beta cubed. So can we try to collect like terms? Those ones with cubed, they come together. Those ones with the square also come together. So this becomes alpha cubed plus beta cubed plus, this one can be added with this, we come out with 3 alpha squared beta plus, this can be added with that, also come with 3 alpha beta squared. So go on, this is alpha cubed plus beta cubed plus, what is common here? What are you seeing there? And there the issue of factorization. So you can see 3 alpha beta is common. 3 alpha beta is common. So we can factorize out 3 alpha beta. So we remain with alpha plus beta. So that when you open, you come out with that, which is equal to alpha plus beta, the whole of it cubed. So our target is alpha cubed plus beta cubed. So these ones are positive. When they come here, automatically they become a negative. So what are we having? We are having alpha plus beta, the whole of it cubed, minus 3 alpha beta into alpha plus beta, which is equal to alpha cubed plus beta cubed. Therefore, alpha cubed plus beta cubed, we are coming out with alpha plus beta cubed minus 3 alpha beta into alpha plus beta. So you will have already come out with this identity. So wherever you see alpha cubed plus beta cubed, just insert in that identity. Then everything will be paramount for you, and you find that mathematics is flowing neatly on your side. So let's go to Roman 3. We need to prove that identity, the identity of Roman 3, which goes that alpha minus beta squared is the same as alpha plus beta squared minus 4 alpha beta. So this time around, where are we going to start from? We are going to start from the original, from the left hand side, which goes that alpha minus beta, the whole of it squared. This is the same as alpha minus beta into alpha minus beta. Then we are going to open. We start with the first is alpha into alpha minus beta. Then again here there is minus beta into alpha minus beta. Then we are free to open up our brackets very well, as we are going to be using that layman's understanding. So we move on. Alpha times alpha, alpha squared. Alpha times beta, minus alpha beta. Again minus negative alpha times beta. We are coming out with minus alpha beta. A negative times a negative, it becomes plus beta squared. So this one becomes, we collect like terms, those ones with a square, we bring them close. So what is it going to be? It's going to be alpha squared plus beta squared minus 2 alpha beta. But class, we should recall back. When I said where you see alpha squared plus beta squared, I said you automatically bring in the identity which you have already proved. So that identity for this case here alone, that one is already alpha plus beta, the whole of it squared, minus 2 alpha beta, then again minus 2 alpha beta. Go ahead, this becomes alpha minus beta, the whole of it squared is the same as alpha plus beta, the whole of it squared, minus 4 alpha beta. But this is what they have already told us to find. This one you can even include and say, but if alone a question comes and say, what about alpha minus beta alone? It means, how can you kill that square? You will automatically take the square root on both sides. And when you take the square root on both sides, this one automatically disappears. We remain with the root of alpha plus beta squared minus 4 alpha beta, where alpha plus beta is standing in for the sum of the roots, and the alpha beta automatically is standing in for the product of the roots. So those are some of the identities which you are going to be following, and we are going now to go to the applicability of them. Before I go for the applicability of them, I would request you first go in for a short break, and when you are returning, if there is somebody who is disturbing you, shift from that position, sit alone, so that we are going to be dealing with the applicability of them. Otherwise, I wish you a good return to the class.